In this video, we are going to look at resolution of forces, how to properly resolve forces. You are given a force diagram that has 4 forces, and you are asked to find theta and p if the 4 forces are in equilibrium. The first thing you have to do is to first of all identify the vertical and horizontal components. So use arrows like I've done here to identify the vertical and horizontal component of each of the forces. For example, for 8.8 Newton force, the vertical force is this and the horizontal force is this. For the P Newton force, this is the horizontal component, this is the vertical component. You can also call it XY component. For this 12.3 Newton force, this is the vertical component or the Y component, and this is the horizontal component or the X component. For the 14 Newton force, this is the horizontal component, that's the X component, and this one is the vertical component, which is the Y component. The next thing you have to do is to give values for those components. The rule of thumb is to apply sign to the side facing the angle of inclination you want to use. Now I'm using 53 degrees for this 14 Newton force, so the side or the component facing 53 degrees is this component, so that means that will be having sine 14 sine 53. So let's go around and check out the component facing the angles of inclination we are using. For this 12.3 Newton force, I'm using 41 degree, which acts to the vertical. Now, because this component of this force is facing 41 degree, I'm going to apply sine to it. So let's check out others. So theta here is what I'm using, which is the angle that force P makes to the horizontal. So that means that the component facing the angle I'm using, which is theta, will be having sine in it. So that's why this component is P sine theta. So also for this force 8.8 Newton, now the angle of inclination is to the horizontal 60 degrees, so it means that component is what will be having sine in it. So that will give me it's 8.8 sine 63. Now, so once you have identified what component will be having sine, others will be cosine. Let me go further to explain why it's like that. Now if I take this triangle, for example, this triangle, if I draw it out and I get this, now applying your trig ratios, to get x you would use sine, so that will give us sine 53 equals opposite, which is x, over hypotenuse, which is 14. So cross multiplying, you get x as 14 sine 53. You can see that this side is the side facing 53. Now let's go straight to this one. This side is the side facing 68 degrees, so your y should be, don't rack your brain too much, your y should be having sine in it. Sine is attached to the component if the component is the component facing the angle of inclination we are using. Now once you are done with that, you need to, the next thing is to identify the directions of this component and place your signs. Some will be in the negative direction and some will be in the positive direction. Now for example, this force is acting against the positive side of the x-axis, so this will be negative. This is positive because it's acting positive side towards the positive side of the y-axis. You can see the y-axis here is positive, so that's why this is positive. This is negative. This force will be negative because it's on the negative y-axis. Now this one will be negative also because it's on the negative x-axis. This one is positive because it's on the positive x-axis. This one is negative because it's on the negative y-axis. This P sine theta and P cos theta are both positive because they are both on the positive x and y axis. Now, so once you are done identifying the directions and placing the necessary signs, so you add up all the vertical components and equate to 0. The reason why you equate to 0 is because from the question we are told that the 4 forces are in equilibrium. So when forces are in equilibrium, the addition of all the forces gives 0. Now, so you add up all the vertical components, the components acting up or down. So this one, this one, this one, and this one. You add them up, equate to 0, solve. So you make P sine theta the subject and get what the value is. The next is to add up all the horizontal components. So the horizontal components are the forces in the x direction, in the positive or the negative x direction. So this one, this one, this one, this one, you add them up, equate to 0. So find from this, find P cos theta. So add up everything here and get P cos theta, and P cos theta is 6.4079. Now once you are done with that, you need to solve out the values for P and theta. To do that, divide equation 1 by equation 2. Now once you do that, you get p sine theta over p cos theta equals 9.5491 over 6.4079. Now don't forget your tan ratio. Tan ratio is given as sine over cosine. So because of that, you can write this quotient as tan. So p cancels p, and what you have left here is tan theta. Now tan theta equals 1.4902. Now taking the inverse of tan of 1.4902, you get 56.1364 as theta. To get p, you are going to substitute for theta in either of equation 1 or equation 2. So let's use equation 1. Equation 1 states that p sine theta equals 9.5491. So replace theta here with this value. Now sine 56.1364 is 0.8304. So p multiplies 0.8304. That equals this. Divide both sides by 0.8304. So p equals 9.5491 all over 0.8304. P equals 11.4994. Approximating these values to one decimal place, your theta would be 56.1 degree, and P to one decimal place is 11.5 Newton.